Hi, my name is Henry Story, and I will be presenting here how WebID functions inside existing browsers and then describe some improvements we're looking forward to. So let's quickly describe the problem that needs solving. The Internet is a distributed set of machines in a distributed namespace, DNS. Each of these machines can run a web server that serves web pages, and each web page gets its name relative to the namespace of the machines it runs on. The universal locators allow us to link pages to form a web of documents known as the World Wide Web. This then allows us to use these documents to describe people in order to create a social web. How do we describe people? Well, we simply use the indirection of hashtag URL to identify users via a uniquely identifying description placed at the document location on the web. So let's just illustrate quickly this distributed social network in Clarezza, which is an Apache incubator project. I've already added two contacts, Tim Berners-Lee and Dan Brickley. Here is Dan Brickley. This is information that this Clarezza instance has fetched from the web, and there are a number of people listed here that are known by Dan. Here is, for example, Misha. This is his web ID, his URL. I click on him. The server goes and fetch his profile on mmt.me.uk, which is different from bblfish.net. And I see this is indeed the Misha I know, and I click here and add as contact. And so now I have one more friend. So as you just saw, it's very easy to add quickly a large number of friends, if only by exploring one's social graph and adding contacts to one's profile. Now if we're going to have hundreds of friends, then the issue of privacy is going to come up very soon. We would like it that not just banks be able to secure their content, but for individuals to be able to restrict access to their photos, party invitations, location data, feeds, etc. This will not work if one is required to log in to each server with a different username and password. And this is what the WebID protocol aims to solve, by integrating open standards already deployed in the existing browsers. The WebID protocol builds very cleanly on TLS and X509 client-side certificates, as they've been available in all desktop browsers since 1997. So what's new? Well, instead of the authenticating server, Alice's server in pink here in the middle, relying directly on a certificate authority to authenticate Bob in blue, Alice fetches information at Bob's profile on the right. This is how TLS was indeed originally conceived of as working, except that instead of using URLs, the thinking at the time was to use X500 directories and LDAP distinguished names. But let us look at how we create a WebID-enabled certificate in the first place. Creating a public key for an end user is as easy as going to his home page and finding a Create Certificate button, which can be a lot more beautiful than this one here, and then clicking it. This gets the browser to create a public-private key, send the public key over to the server, and the server signs it and sends it back. We can then look at the key here and the details, and the key contains my name. It is got a public key in it, and the subject alternative name, which is my web ID. By refreshing this page, the browser, we see that the web page contains the public key here, which should match the one in the certificate, as we will see a little bit later. So, what can I do with this web ID? Well, I can use it here on a service that's just been set up, so I've never visited before, and it asks me to authenticate. So I click here. I get to select a certificate. I choose this one, and there we go. I get logged in, and what the nice thing is that the server recognizes my name, recognizes and puts my picture up and allows me to type something fun. So what exactly happened when I clicked that login button? If I am in the role of Bob, in blue, in the sequence diagram here, trying to connect to the remote web server in pink, then we can see the following. In 1, I click the login button, or link, pointing to an HTTPS endpoint. In 2, that server requests a client certificate. This is part of the HTTPS session. In 3, the browser asks me for a certificate. Now, there are a number of ways this can look in different browsers. The Apple iPhone selection box is the most intuitive here, and the Firefox is a disaster. In 4, then, Alice's web server verifies with a public key sent in the certificate that a token signed by my browser was signed by the corresponding private key. Until here, all is pure standard TLS. Alice's server extracts the WebID, and in 5, it dereferences it using HTTPS, if the WebID is an HTTPS URL, and if it were an FTPS URL, it could dereference it using the file transfer protocol. The return document is then saved in a local cache. In 6, the server, the authentication agent, verifies that the public key in the certificate matches the public key in the remote profile. If these keys match, then authentication has succeeded and the server knows one thing and one thing only, and that is that the remote agent is identified by that WebID. Now, where traditional PKI's metaphor closely resembles that of a passport signed by one of a few trusted parties, in the case of WebID, we're closer to something like this. The face on the picture is the public key. My actual head is the corresponding private key. And if the picture fetched by dereferencing the URI matches the picture sent by my head, visually, then the guard knows my name to be that WebID, nothing more. So what does that give the guard? Well, it all depends very much on the guard. If he is a shopkeeper and I'm just browsing, then he can choose, in all interactions with me, to take me at my word, as long as it does not commit him to anything. If he is a guard at a party, he may check my URL on the guest list. And if you are at an airport, you just might want to take your traditional passport in case there's a problem with the internet connection. So at 7, given the criteria of access to a resource, and given trusted information, the guard can deny or authorize access. So in summary, the key advantage of WebID is it's using existing infrastructure implemented in billions of browsers to enable a global and decentralized identity system with which we can create a referential web of trust. The advantage of this indirection is that no attributes need to be placed in the certificate. Then they can be placed on the server remotely, where simple web-based RESTful access control mechanisms can be used to decide who sees what. The web of trust itself can evolve without the certificates changing. There's no center of authority furthermore, and it's easy to create throwaway certificates. So how can browsers help? The key, most important improvement would be for browsers to make the identity a user presents to the world visible and directly controllable. The work by Asa Raskin at Mozilla is exactly right and just needs to be adopted. The user should be able to see not just which server he is connected to, but if he is logged in, and be able to change that in the browser. Because WebID certificates contain a URL from which the browser can fetch more info, a picture of the user can be displayed, for example. And it can also link to the user's home page, where he can edit his profile. This, in fact, already works, though in a not such a beautiful way. Secondly, it would be great if operating system vendors improved browser support for crypto keys. We have a demo where we use the German Privacy Foundation stick here shown to create a WebID cert using keygen and then using it in an internet cafe. There is a lot of demand also for access to the keys via standardized API for signing and micropayment needs. Finally, please join us on the W3C WebID Incubator Group